Alrighty, we're recording now, so thanks for joining me. I've got quite a few people here. So as I've learned, WebEx is different now. I can easily share like one thing, but not like my entire desktop for some reason. So regardless, I'm going to just kind of put everything together in Excel. So for chapters 5 and 6, what I did was just put stuff in Excel that I want to show you that will help you do the homework problems. So that's what you see on the screen. This is kind of a slice and dice from the chapter 4 Excel that I gave you that does the time value of money. And chapter 5 deals with bonds. And in bonds, all we really have to do for time value of money is solving for the interest rate, solving for I, and doing the present value of an ordinary annuity. So that's what I gave you. I just took those from that Excel file I gave you from chapter 4. And then every chapter has what they call a toolkit Excel. And for the most part, I kind of just put them out there for your own review and your own just to look at and get used to using. For chapter 6, I took a section of it and I just copied and pasted it into this file right here. And what I'm going to do is I'm going to give this file to everybody. It'll help you out to do your homework. So I decided to show it to you tonight, and then I'll send it out to everybody after that. So this file is just a copy and paste of that Excel file, the toolkit for chapter 6. We'll come back and take a look at it, and I'll show you what this is used for. Okay, so I want to look at problems from chapter 5, and we'll do chapters 5 and 6 tonight. And so chapter 5 dealt with bonds. And most of the questions deal with how to value a bond and how to calculate yield to maturity or yield to call or something like that. And we're going to look at bonds from an annual payment perspective and a semi-annual payment perspective. So the first question I'm going to look at, and this is coming from the back of the chapter. So if you have your ebook, the questions that are just right here, I copied and pasted them from the ebook. And so in the back of chapter 5, there is problems, and that's just where these are coming from. So that's my source, directly right from the ebook. So it says here for bond valuation with annual payments, Jackson Corporation bonds have a 12-year remaining to maturity. Interest is paid annually. The bonds have a $1,000 par value, and the coupon interest rate is 8%. The bonds have a yield to maturity of 9%. What's the current market price of the bonds? So when you're doing a bond valuation, what you're doing is you're computing the present value of the bonds, okay, the present value of the bonds. And so to do that, we're using the time value of money calculation. So I'm going to show you the section up here, and we're going to come back and look at this quite a bit. So present value of an ordinary annuity, all bonds are ordinary annuities, if that helps. So let's go back. Let's go back to the question. So we've got 12 years until maturity. Interest is paid annually. Bonds have a $1,000 par value. The coupon rate is 8%, and yield to maturity is 9%. Okay, so that's kind of the inputs. We'll come back and solve for those up here. So the coupon payment, it mentioned 8%. So what you do is you take the $1,000 face value, you multiply that by the coupon interest rate, which is 0.08. It gets you $80. The future value is a $1,000 maturity value. The interest rate is the 9% yield to maturity. Let's show you where that was right here. And then we have 12 years remaining until maturity. 12 years. And the answer is 928.39. So this is that present value formula from Excel. And a bond is made up of two series of cash flows. It's made up of interest payments and the principal repayment. So I'm doing the present value of both of those cash flow streams, the annual coupon payment and then the maturity payment, the face value. And I get to 928.39 as my answer. That's the answer is 928.39. Question 2, it says yield to maturity for annual payments. So this one, when you hear the term yield to maturity, that's solving for an interest rate. Yield is interest rate. So Wilson Corporation's bonds have 12 years remaining until maturity. Interest is paid annually, and the bonds have a $1,000 par value. Coupon rate's 10%. The bond sells at a price of $8.50. what is their YTM, or yield to maturity. So what that means is, if I were to buy that bond as a bond investor today, I buy Wilson Corp's bonds, and I intend to own these bonds until they mature, the yield to maturity is the return that I would expect to earn by owning these bonds for the next 12 years. Okay, so it's called YTM, or yield to maturity, solving for an interest rate. Okay, so this one is solving for I, interest rate, and with this one, the payment was 10%. So the coupon payment was 10%. You take $1,000 times 0.1. The future value was the 1,000. The present value is what the bond sells for today, and that was, and all of a sudden, there we go, $850. And this was a 12-year bond, and I get 12.48%. Okay, so that's the answer. Now the key with future value, present value when you're solving for I is typically you enter the present value as a negative and the future value as a positive. Okay, so kind of just keep that in mind. It really wouldn't matter. I can do one, the other one, I can do this backwards. It'll still give me, and it gives me a different answer. So that's what I have to be worried about. So generally the future value is positive. Present value is a negative. Okay, so that gives you 12.48%. I kind of, when I did the lecture PowerPoint for this chapter, the PowerPoint itself actually does some of these examples also, and I kind of went from that PowerPoint to this Excel file and showed you some more examples there too. So just kind of keep that in mind. So the yield to maturity on that bond is 12.48%. Question 3, it says current yield for annual payments. It says that Health Food Corp's bonds have 7 years remaining until maturity. They have a face value of 1,000, yield to maturity of 8%. They pay interest annually and have a 9% coupon rate. What is their current yield? So with these kind of calculations, with a bond, when you own a bond, yield to maturity is made up of two components of yield, current yield and capital gain yield. So it has both in there. And so we have to figure out a couple of things first before I can go and figure out what the current yield is. Okay, so one of those things I have to figure out is what is the value of the bond. So the first question really with this particular question is, what is the value of the bond? I have to know that first because there's a formula I have to deal with. Now, let me kind of show you the formula. And the current yield, I'm going to type it in here. So I just say CY for current yield, and that equals the annual coupon I can type and talk here, payment, and I didn't spell that right. It's going to drive me crazy if I don't spell that right. There we go. And I divide that annual coupon payment, I divide that by the bond's current price. Okay, so annual coupon payment divided by current price is my current yield. Now, nowhere in here does it tell me what the bond price is, so I have to figure that out. So I don't know what that is yet. I do know the coupon payment. That's easy. I've got that because 9% times 1,000 is my coupon payment, so there's no question about that. So let's go ahead and solve for what the value of the bond is. Okay, so as we mentioned, the coupon payment is $1,000 times the 0.099%. The future value of the bond is 1,000. The market rate of interest on this bond is 8%, and we have 7 years left until the bond matures. And so my price of the bond is 1052.06. 1052.06. So I'm going to put in the price right here, 1052.06. The coupon payment was that $90, $1,000 par value times 0.09 for 90. And so my current yield is 90 divided by 1052.06. I get 8.55%. 8.55% is my answer. Okay, and this would be on slide 21. So I'm just going to type in a note right there so you see it. If you look at your PowerPoint for chapter 5, you want to take a look at slide 21. Okay, so that's the one you want to take a look at. That'll kind of give you the formula here too. So just FYI. Okay, I'm going to skip a few problems and I go to question 7. And question 7 deals with semi-annual payments. In reality, most bonds pay their interest payments twice per year. So semi-annual means twice per year or every 6 months. And that's really what you would expect to see. So the vast majority of bonds, that's the deal. So let's go ahead and solve for this with semi-annual in mind. So it says that Renfro Rentals has issued bonds with a 10% coupon payable semi-annually. So that's the key, is the problem told me semi-annually. These other problems mentioned annually. This one says semi-annually. The bonds mature in 8 years. They have a face value of 1,000, yield to maturity of 8.5. What is the price of the bonds? Let's go ahead and solve for that. And so there's some steps you have to go through when that is the case. So the steps are, you double the n, you take the 8 and you divide it by 2. So think about that. For 8 years, every 6 months there'll be a payment. So 2 payments per year for 8 years. That's 16 payments. Okay. Also, the coupon rate, 10%, that's an annual coupon. So I have to divide that by 2 to make it be a semi-annual number. So my coupon rate is 10% divided by 2. And my yield to maturity is 8.5% divided by 2. Okay, so I take the interest rates and cut them in half, and I double the n. That's the process you have to go through when you're doing a semi-annual conversion. Okay, so let's go ahead and do that. And so for the payment, it was $1,000 face value times 0.1 divided by 2. Okay, so I get $50. The future value is the same. It's still $1,000. My yield to maturity was 8.5, and I simply just divide that by 2. So I get 4.25. Oops, I'll have to take the 0.025. So watch your signs there. 0.085 divided by 2 is what I'll have to do to make that work. So I get 4.25%. And then my N, that was an 8-year bond, semi-annual payments, double that times 2, I get 16. And so I get, my answer is 1085.8. Okay, so when you see the word semi-annual, or they might just say interest was paid twice per year, whatever the clues are in the question, just make sure you adjust correctly when you do the bond valuation calculation. Otherwise, you'll have the wrong answer. Okay, so that was question 7. And then question 8 says, Thatcher Corp's bonds will mature in 10 years. The bond has a face value of $1,000 with an 8% coupon paid semi-annually. The price of the bonds is $1,100. They're callable in 5 years at a call price of $1,050. So there's 2 questions then. What's the yield to maturity? And what is the yield to call? Yield to call is the yield I would expect to earn if the bonds are called. Okay, so yield to maturity, the yield if I own the bonds until they mature. Yield to call is the yield I get if the bonds are called. Okay, so I'm going to calculate both of these. So the chapter talks about a callable bond and what that is. The callable bond is a bond issued by a corporation, and they have the right to buy it back from you at a specified price. It's usually a good deal for the corporation that does that, because they will call it if they can reduce the interest payment. So if market interest rates have come down, what they will do is call the bond back and basically reissue new debt, pay off the old debt, and save on interest. So it's actually a very common thing. But as an incentive to get investors to buy the bonds, they'll offer this call premium. So instead of paying you $1,000, I'll pay you $1,050 in order to buy that bond back. So that's kind of the situation behind it. Okay. So I'm solving for yield on semi-annual bonds. So I go back to the solving for the interest rate up here. So I'm going to do this calculation here, solving for I. This will do 2 calculations. One of them is solving for YTM, one solving for YTC. Okay. So again, we have to kind of look at the facts of the situation. Going back to the question, just to remind ourselves what the numbers were under question 8. So let's look at the maturity first, the YTM calculation. So it matures in 10 years. So semi-annual, 2 times per year for 10 years is 20. The coupon rate's 8%, so I divide that by 2. And then I have to take a look at what the price is. The price of the bond today is $1,100, and the maturity value at YTM would be $1,000. Okay, so let's go back and calculate that. So we'll do this one right here. So we're going to take $1,000 and then multiply it by the coupon, which is 0.08. Then I'll divide that by 2. Okay, and then under YTM, the face value would be 1,000. The present value is what I pay for the bond today, and today I'm buying the bond for $1,100. And then if it's a yield to maturity, that's for 10 years, and I'll double that times 2. So I get 20. Now here's the challenge with this question. When I do a solving for an interest rate using a semi-annual calculation, I have to double the answer. So I have to take that 3.31 and I have to double that. So take that times 2, and let me format that. Okay, so my answer is 6.62. I have to double the answer. If I don't double the answer, and you're doing this in MindTap, and you go type in 3.31, it'll come back and say you got it wrong, right? So it's an easy mistake to make. So here's the big hint of the day. If you're solving for an interest rate using semi-annual, double the answer. Okay, so the YTM is 6.62. In fact, I'm just going to type that over here, 6.62, just so we remember what the number is. Okay, let's do the same thing now for yield to call. So go back to the question down here. Yield to call, just to refresh our minds with the numbers to input. Now this is based on 5 years, and then the call price will be $1,050. We still buy the bond for $1,100 today. So just a few different inputs here. So the future value becomes $1,050, and then it will basically call in 5 years. So I'll just take 5 times 2, and so I get my answer, which is 6.49. So then I just type in 6.49. So that was yield to call, YTC, and 662 was my yield to maturity. Okay. So that'll be a very common type of a question that you'll get for the bond chapter. They'll have you calculate both things. Okay, now let's go ahead and take a look at one more for chapter 5 and move on to chapter 6. For chapter 5, the final question. Actually, no, I may have one more than that. Looks like I got 510 right there too. Actually, I got a few more, my bad. So question 9, right here, the Garrity Company has 2 bond issues outstanding. Both pay $100 annual interest plus $1,000 at maturity. So we're looking at annual. It says bond L has maturity of 15 years. S has a maturity of 1 year. So think of L as for long, S is for short. And question 1 says, what will be the value of each of these bonds when the going rate of interest is 5, 8, and 12, assume that there's only one more interest payment to be made on bond S. And then question 2 is, why does a longer term 15-year bond fluctuate more when interest rates change than on a short-term bond? Okay, so let's go ahead and solve for these, and we're going to compute the value. So let's do the we'll do the short bond first. And so it says here, both pay $100 annual interest, $1,000 at maturity, and then we'll just go ahead and plug in the new interest rates, the going rates of interest, for what these are. Okay. So let's go ahead and solve for these. So let's do S first, and so we have just one interest payment left. With S, let's go ahead and we'll go ahead and choose the 5% number first. And then we've got the 1,000, and we've got a $100 annual payment. Okay, so I get 1047. So we're going to build a little table here, and we're going to build L and S. Okay, and then we're going to have the interest rates. We're going to have 5%, and then we'll have 8% and 12%. This is a good exercise to kind of help you understand how interest rates affect, and maturity both affect the value of a bond. So S was 1 year. Let's just put a 1 there. and L was for 15 years. Okay, so S is 1 year at 5%. The value of the bond is the 104. I'm just going to round and go 104.8. And then we'll do the same thing for 8%. And now I get 1018. And then we'll do the same thing for 12%, and I get 982. Okay, I just rounded the numbers. So what I want you to see as a pattern is that as the interest rate goes up, did you notice that the bond price goes down? So just kind of notice that too. So interest rates definitely impact bond price. Just want you to kind of remember that. That's some concept type questions that you'll get. So as the interest rate went up, the bond price went down. Let's do the same exercise for 15 years, and that's for the L. So I'm going to put 15 here. I'm going to start at the lowest number here first. I'll go to the 5. So at 5%, the value is 1518. I'll change that to 8%. It becomes 1171. At 12%, then the final number, it becomes 863. Actually, 864 if I round. Okay. So what I want you to see is, and remember the par value, the future value is $1,000. So in a 1-year maturity, if I'm comparing all these numbers to 1,000, okay, and it didn't change a lot, right? None of these numbers is that far off of $1,000. But on the 15-year, notice how far away these numbers are all from $1,000. So both interest rates changing and the time to maturity impact the price of a bond. The longer we wait until maturity, the bigger the impact that there is on a fluctuation of interest rates. So just kind of a concept question that you can visualize. So if you get some concept questions that say, if this interest rate changes, then what? This is a good exercise to kind of visualize and go through and do. So don't be afraid to take some numbers, plug them into this, and just to say, as interest rates go up, what happens to the bond price? Which is what I showed you here. Okay, so that was question 9. Let's take a look at question 10. I got ahead of myself thinking 9 was the last one. 9 is not the last one. I've got a few more left. Okay, it says for Brownstone Corporate's bonds, they have 5 years remaining to maturity. Interest is paid annually. Bonds have a $1,000 par value and a coupon interest rate of 9. So what is the yield to maturity based on a market price of $829 and 1104? So let's go ahead and compute that. So I'm solving for I, and this is annual, so I don't have to worry about the semi-annual doubling thing at all. So let's just go back to solving for I. And in the problem, they mentioned that the future value is 1,000. And then in the first one, we're going to spend $829 to buy the bond. And it was a 5-year bond, and then the payment was $90. Okay, let's go back and just make sure everybody sees that. I'm going to take out that doubling thing because we don't need that right now. So I'm just going to show you, go back to the question here and show you those numbers. Okay, so $1,000 par, the coupon interest rate is 9%, so 9% times 1,000 is my 90, and 5 years. So the first part of the question is, what's the yield to maturity at 829? So at 829, yield to maturity is 13.982. Okay, so I'm going to just plug that number right here and go 13.98, and that was at a price of 829. Okay, let's do the same thing, only now the price of the bond, let's go back and take a look at that again, is now it's higher. It's 1104. 1104. Let's go plug in that new number. So minus 1104. Okay, and I get 6.5. 6.5 when the price is 1104. Okay, so here's what I want you to notice is, notice how that price I paid dramatically impacts the yield to maturity. So the higher the price that I pay for the bond, the lower the YTM. Okay, so that's part of what I kind of want you to visualize with that question. So the question says, would you pay $829 for these bonds if you thought the appropriate rate of interest was 12%? Okay, let's go back and take a look at the YTM. So at 829, right, let me change this back to 829. YTM was 13.98. And so what they're saying is if you felt like the appropriate yield was 12%, would you buy the bonds? Yes, 1,000 times yes, right? Because if I believe the required return is 12% at the price of $8.29, and it actually earned practically almost 14%, I'd be yes, I want to own those bonds, and yes, I would buy those bonds. Okay, so that's part of the reasoning and why you would do this kind of calculation. Okay, and then we'll do question 11. And question 11 says, what's yield to call and a realized rate of return? So it says here that Goodwin and Wolf, G&W, issued a bond 7 years ago. The bond had a 20-year maturity and a 14% coupon paid annually, a 9% call premium, and was issued for par at par $1,000. Today, they called the bonds. The original investors had expected G&W to call the bonds in 7 years. Excuse me. What was the yield to call at the time the bonds were issued? So we have to kind of think back 7 years ago. And so it's not really any different kind of a calculation. What's unique is kind of the way they word the calculation. And the key thing to keep in mind here is when the bonds were issued 7 years ago, the call premium was 9%. So just imagine 9% times 1,000 is 90. So the call premium would have been 1,090. Okay, so that's maybe one of the little twists for this particular question. So let's go back and do the calculation of YTM for this one. And it was based on an annual payment. So that makes it just a little bit easier for us to take a look at. So the payment was a coupon rate of 14. So we take 1,000 times 0.14. And the future value then is the 1,000 times 1.09, and 9% being the call premium to get to 1,090. And then the present value is what the bond sold for when it was originally sold, and that is, it told us it was sold at par, $1,000, and it was for 7 years. Okay, so my YTM is 14.82. So just the way they asked that question was just a little bit different, but you've done a few chapters already now. You've done chapters 2, 3, and 4 so far, and you kind of know that sometimes I like to twist the questions a little bit to kind of get you thinking about these. And so to me, it's kind of one of those questions where they kind of make you think a little bit harder about how to get to the particular inputs. But the whole point was what was the yield to call essentially when the bond was issued 1,000 years ago, or 7 years ago. I said 1,000, 7 years ago. It's been a long day already. Okay, so that was question 11, and we'll do one more, question 12, and move on to we'll move on to chapter 6. So for question 12, it says here, 10-year, 12% semi-annual coupon bond, par value of 1,000, may be called in 4 years at a call price of 1,060. The bond sells today for $1,100, and we're assuming it was just issued. So questions then, what's the bond's yield to maturity, its current yield, capital gain, loss or yield, and yield to call. So let's do yield to maturity first, since that's question 1. So it's a 10-year bond, 12% semi-annual coupon, par of 1,000, sells today for $1,100. So we'll do yield to maturity on this bond. So let's go ahead and plug in my numbers. I gotta dial in my answer here. Let's see. So this was a 10-year, so let's do the end first. 10-year bond is yield to maturity times 2 because it's semi-annual. We paid for this bond today $1,100. It will mature at $1,000 in 10 years. And then the coupon payment is, let me look at the right number here, is 60. And the 60 came from right here. So 12% semi-annual coupon. So I just want to make sure everybody saw that. Okay, so we'll take 1,000 times 0.12 divided by 2. Okay, and so I get 5.18, but now I have to double that because it's semi-annual times 2, and my answer then is 10.37. So YTM is 10.37. I'm going to put that number in right here, 10.37. Okay, there's my YTM. Now let's do the same thing for yield to call. We'll go back down to the question, and we'll take a look at that. So yield to call, and let's do it. That's question 4. And so we'll do that one, and then we'll come back to answer questions 2 and 3. So yield to call is 4 years at a call price of 1,060. Okay, so it can be called in 4 years. So N would be 4 times 2, which is 8. And then the call price is 1,060. So yield to call is 10.15. 10.15. I'm going to put that in right there. Okay, so YTM is 10.37. Yield to call is 10.15. So let's take a look then. And the next question is the current yield. So let's go to question 2 down here. And they say, what is the bond's current yield? Well, if you can remember what current yield was, I had that formula I had kind of squeezed in up here, right here. Let me just copy this one, and we'll just plug it right in down here. And we'll go put that right here. Okay, so my annual coupon payment, so that was 120. That was the 12% times 1,000. And I divide that by the bond price. And the bond price was pretty simple. It was just the $1,100. So my current yield is 120 divided by the 1,100. And I get, let's just turn that into a percent with 2 decimal points. And we get 10.91%. So then part 3 says, what's the bond's capital gain or loss yield? So we have to take the yield to maturity. And the yield to maturity was the 10.37 right here. Okay, and so the formula is this. Let me just kind of type in a formula, one more formula for you guys. So yield to maturity, YTM, that equals current yield plus capital gain yield. Okay. So I know my current yield is, I know my YTM is 10.37. I know my current yield is 10.91. So that leaves me with a negative current gain yield of 0.54. Okay, so that's how you do that. So 0.54 would be the answer. Slides 21 and 23. Have these formulas on them and walk you through this really well. Slides 21 and 23 of the Chapter 5 PowerPoint. So always feel free to look at those when you're doing your homework, but that's how you do this one. So you will have questions exactly like that in your homework. Okay, let's move on to Chapter 6. So we'll move away from the bond chapter. And Chapter 6 deals with risk and return. Risk and reward would be kind of a good way to frame it. And the purpose of this chapter is to help us kind of understand interest rates and probabilities, and help us understand if we build a portfolio, do we have an efficient portfolio that properly matches risk and return. That's really the goal of Chapter 6. We're going to move on to Chapter 7 next week, which is the stock chapter. And so Chapter 6 is kind of a warm-up to the stock chapter. So that's kind of the purpose of it. And then one of the big topics of Chapter 6, it's a concept called beta. And beta is a measurement of risk. And a beta of 1 for a stock means you have the same risk as the market. So the market has a beta of 1. And so what you do is you compare, and how beta is calculated, it's a standard deviation over time of how a particular stock price changes when the market changes. So let's just say, for example, if the market went up by 10%, you would look at a particular stock and go, what did that stock do when the market went up 10%? Did it also go up 10%? Or did it go up by 12%? Or did it go up by 8%? And that's what you're looking at. And you're tracking that. And most websites that track this, like Yahoo Finance is a good one. And the recording I did for the chapter, I kind of show you that. They do like a 3-year running average, and that's pretty common. So just know that beta is a number you can easily look up, and it's a measurement of risk. So just keep in mind, for a stock, a beta above 1 is riskier than the market, and a beta below 1 is less risky than the market. It's that simple, okay? And websites have these beta numbers that you can just grab and use, okay? So we're going to have an investment club has 2 stocks in a portfolio. 20,000 invested in stock with a beta of 0.7. 35,000 invested in a stock with a beta of 1.3. What's the portfolio's beta? And thankfully, it's a nice and easy calculation. I'm going to take the 20,000. I'm going to add that to the 35,000. Okay, and I'm going to sum that together. Okay, so the sum of these two numbers is 55. And that's the value of my portfolio. Next, I can basically just say, what's the percent of each one to the total? So 20 divided by 55 is 0.36. 35 divided by 55 is the inverse of that, 0.64. I can sum that just to make sure it equals 100%, and it does. And then the next thing to do would be to say the beta for the $20,000 stock is 0.7. The beta for the $35,000 stock is 1.3. And all I have to do is multiply these by each other. 0.36, the percent, times the beta. And then 0.64, the percent times the beta of 1.3. Then I can just add those down, and that's the beta of my portfolio. So if I just simplify that down to 2 decimal points, which is most likely what MindTap will want you to do, the beta of my portfolio is 1.08. And that's very common. And the chapter has a lot of information about why you would have a portfolio that's made up of more than one stock. You're diversifying, you're reducing your risk, and you're getting a better beta that matches the risk you're taking and the return that you should get. Okay, so that's how you would calculate what they would call a portfolio beta. Question 2 says AA Corporation stock has a beta of 0.8. The risk-free rate is 4%, and the expected return in the market is 12%. What's the required rate of return on AA stock? So a few concepts from the chapter that they mention is we have to use what they call the CAPM, C-A-P-M. It's called the Capital Asset Pricing Model. And that puts in a few things that help us calculate what's the required return on a stock. The risk-free rate is the 10-year T-bond from the Treasury. So the U.S. Treasury, the Federal Treasury, issues a 10-year T-bond, and it's considered to be a risk-free investment. And the reason it's risk-free is because the Treasury can issue, they can print money, and nobody else can. So because they can print money, it's assumed that those will never default, therefore they're risk-free. So you can always put your money in something risk-free, and there's zero risk. Of course, the return's very low. Okay. Now, the market is basically just saying, what does the market get me as a return? And in this example, they're saying the market return is 12%. So the CAPM, the Capital Asset Pricing Model, is this. So we're computing what they call the return, which is R, on a stock. So R sub S is the formula, and then we're computing that equals R sub RF, RF meaning the risk-free rate, plus the difference between the return on the market, R sub M, minus R sub RF, the risk-free rate, multiplied by beta. Oops, I made the right number of beta. That's the formula right there. Okay, that's the CAPM formula called the Capital Asset Pricing Model. The goal of that model is to say, for this risk, what's the return that I should be taking? Okay, so let's plug in our numbers so we can solve for this. So it says here that the risk-free rate is 4%. So I'm going to put in plus 0.04. Okay, and I'm going to add to that the difference between the R sub M, which is 0.12, minus the 0.04, and I'm going to multiply that by the beta, which is 0.8. Okay, so there's my formula. Let me just type it like this So you see it like that, okay? And then, so those are the numbers. I'm going to copy and paste it and put it right below there, right here. And I'm going to take out this little apostrophe so it computes this time. Okay, so now I've got my answer. And whoops, I got to fix my formula here. And let's see, what did I do wrong? Right here, I got to put the times right here. That'll work. So 0.104, let me convert that to a percent. That becomes 10.4%. Okay, so let's think about that answer and why that answer makes sense. So remember that the beta of the market is 1. And right now the market gets me 12%. Okay, so the general market should get me a 12% return. The beta on this stock is 0.8. Okay, so that means this stock has less risk than the market. So therefore, I get 10.4% return, which is lower than the 12. Well, that makes sense because I get a lower return than 12 on this particular stock because this stock is less risky than the market. Okay, so that equates to 10.4%. And that's how you build a portfolio. Okay, when you make that investment, you know this is the required return that helps you make an investment decision. Okay, so the next one's question 3. And it says, suppose that the risk rate's 5 and the market risk premium is 7. What's the required return on the market? The stock with the beta of 1 and the stock with the beta of 1.7. So when you see this little combo right here, where let me highlight this, where it says the R sub M minus the R sub RF, that's called the market risk premium. Okay, so I'm going to type in a formula here. So what I call RP sub M. That's the market risk premium, and that equals this. That equals the return on the market minus the risk-free return, R sub RF. Okay, so that's called the market risk premium. So RM minus RF is called the market risk premium. Okay, in this question, they just said the risk premium is 7. So basically, RM minus RF equals 7 is what they're telling me. Okay. So with that information, then I can go ahead and plug in my numbers and come up with what is the market return. Well, that's pretty simple. It's the 5 plus the 7. Okay, so the 5 plus the 7 is the return on the market. So basically, it's 12%. Plus 5 plus 12. I'm sorry, plus 5 plus 7 is 12%, and that's what the number 1 is. It's the 5 plus the 7 is the return on the market. The stock with the beta of 1. Well, the return on the market is 12, and the market return is 1. The beta of the market is 1, so the answer is still 12. Nothing's changed here. Okay, so the answer for 2 is still 12. The bottom one, though, now it's going to be different. A stock with a beta of 1.7, that's quite risky, right? So I actually would have to take that 12% and multiply it by the beta of 1.7, and I get 20.4%. Would be my answer. I'm sorry, no, that's not correct. My bad. I can't use it. I can't do it that way. I got too far ahead of myself. Okay, so my bad. Let me type out a better formula here. I got it way ahead of myself here with that one. So in this one, R sub S, okay, the return on that particular stock, equals R sub RF plus the market risk premium, RPM. Okay, and then we take that RPM and we multiply it by beta, okay, times B. That's really the formula. So think of it from this perspective. I want the risk-free rate of 5 plus I want to then multiply the 7% of the market risk premium, 0.07, times the 1.7, and that will give me my answer. Okay, and I get 16.9%. Let me put that into a percent, and that's the answer. Okay, I got totally ahead of myself on that one. Okay, so 16.9% is the answer to that one. Okay, now what the chapter does from there is it kind of moves on to how to calculate distributions. And a lot of what the kind of the second half of the chapter, kind of the first half talks about beta and the CAPM and that calculation. Then it moves on to what they call expected returns. And we have probabilities. So when you make an investment, professional investment people will look at probabilities. And we're not really trying to figure out what the probabilities are. They're just going to give those to us. And what we're trying to figure out, though, is what will the return be on a particular investment based on probability, and what's the expectation using rates of return and standard deviation. Okay, so that's why I'm going to have you use the Toolkit Excel. In this exact file that I'm using, I'm going to send out, I need the recording we'll have to process, and in the morning, tomorrow morning after I record this, I'll send out the link to the recording and this particular file. But as I mentioned, it came from the Toolkit Excel. And so this is the exact numbers from the question. So this is question 6-5 from the back of chapter 6. And the question is basically a stock has this distribution, this probability of return. And it's basically, so demand for the company's products would be weak. There's a 10% chance of that. Below average 20%, average 40, above average 20, strong 10%. And this would be the return on the stock, the return on the company based on that. So if they have a really bad sales year, they're going to lose 50% and so on. Okay. So what this file does is it computes the expected return based on that. So I've got the probabilities, I've got what we think the return will be, and then this formula here, it just multiplies the two by each other. It takes 1 times 2, and then I take this and I sum those all up, and that's 11.4%. So the answer is 11.4%. But then the question is, what's the standard deviation of that? Okay, so the standard deviation is computed right here. It's taking this formula right here. It's taking the 50%, and it's multiplying it by this amount right here. And you can see then I get 0.614. And then I'm squaring that number. I'm just taking that and I'm squaring it. And then I'm taking the probability and I'm multiplying those two by each other. I add those all up and I do the square root of this. And that's how you do standard deviation. So I definitely do not expect you to build that from scratch. You will have questions that deal with this. And so you can use either this example or the Toolkit Excel as ways to calculate that. Either way, it'll work. Okay. So the Chapter 6 Toolkit Excel or this file will get you those answers. So all I did is I kind of did that ahead of time. I just dropped in the probabilities and the percents given to us in the problem, and the Excel magic did the rest. Okay. And so the purpose of doing this is basically, what's my expected return at 11%? And then the deviation kind of helps me understand how probable will this happen. Okay, that's kind of the whole goal of what we're trying to accomplish here. And that's a big deviation, right? So that's kind of like, it doesn't give me a lot of confidence in this. That bigger number kind of reduces my confidence level. Okay, there's just one more. I'm going to do question 6. And question 6 then, let me show that one to you. So question 6 is right here. And these are the numbers from the problem. And for this one, they want us to do probabilities for 2 different stocks. Or I should say just stock J and M for the market. So we want to run everything for 2 things. Stock J and the market. And market here is the 15, 9, 18, and J is 20, 5, and 12. I plugged in one of these, and we'll go back up to this one. So this is question 6.6. And I did the, let's see, I did the market. This is the market numbers right here. So it's 0.3, 0.4, 0.3, and the market was 15, 9, and 18. I get a 13.5 expected return with a deviation of 3.9%. Now let's plug in stock J, and stock J had a 20, a 5, and a 12. And so I get 11.6 with the larger deviation. Okay, and that's the whole point of doing that exercise, is that helps me decide, is this stock worth doing compared to what the market gives me, right? So let me go back and plug in the market numbers. It was 15, 9, and 18, and then I get a 13.5% return with a 3.9 deviation. And I compare that to 20, 5, and 12. I get a lower return and a higher deviation. So this stock is not a great, this stock wouldn't excite me compared to the market. Okay, so the return on that's lower than the market with a higher deviation. So it wouldn't excite me as an investment. And so that's just one thing that you can do. Now, of course, how do you get these numbers in reality? It's judgment. It's basically your best judgment. And that's the challenge when you are doing these calculations, is you're making educated guesses, and it's kind of above and beyond the scope of this class how you go about doing that. We're just going with what they gave us. In reality, you're making educated guesses about the future. And that's really what a lot of predicting the return of a stock or the price of a stock is really about, best guessing the future. And that's kind of what they're doing with these probabilities and the returns. Okay, so just FYI. So you'll use that for some of your homework for Chapter 6. So Chapter 6 is very much about interest rates and probabilities, the CAPM formula, matching risk and reward, risk and return, making sure that we have an efficient portfolio, the diversified portfolio. Those are a lot of the topics from the chapter. And that kind of helps set the table for what we'll learn in Chapter 7, which will be one of the chapters we cover next week. Any questions about that? There's a lot of information, but this will give you really good examples to follow and to do your homework and help you grasp it and understand it and try to figure out, why are we doing what we're doing? That's the whole point. Any questions from anybody? Okay, yep, you're welcome, Marlene. Okay, I'll leave it at that. Obviously, if anybody has questions, feel free to email me. You can text me, you can call me, my cell phone, send the syllabus. Any of those methods. I'll send all this out to everybody tomorrow. Okay, thanks.